There we go.
Okay, welcome to the January 23rd, 2024 session of Tangerine SDR and ham side technical session with a emphasis on Clementine development. So this week I've been actually repairing some stuff around the house due to some frozen water pipes. So I lost my laundry room for a week or so, and we're slowly getting that fixed. But I did get set up better in the house. I had the plumber put in off switches or valves, which makes sense. Anyway, I got that done, and I've been installing different kinds of software to try to figure out how they work. Some stuff that Mike Howen got me started on, and actually keeping all my radios running. So next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks, Steve. The thing I've been focused on most regarding research right now has been continuing to work on this geophysical research letters manuscript about large-scale traveling atmospheric disturbances and medium-scale traveling atmospheric disturbances. And the project is coming along, but these edits always take a little bit more time than I'd like. So, but I'm still working on it, and it's I think it's coming along, just still needs a little bit more of a push. So working on that, getting ready for classes starting. Over the weekend, my family and we went out to well, it was Anthony's 5th birthday on Friday, so it was really exciting. And we took him to Kalahari, which is this indoor water park, on Friday and Saturday. It was great. And that was one of the days where we had the snowstorm. Unfortunately, Kalahari is only 30 minutes away from us. So we made it there in this snowstorm and then went to a water park in like 5-degree weather. So it was wonderful. Back
Well,
to
that's
net.
pretty good.
Yes.
Very good. Next on the list is
Dave,
Franco.
do you want to call Tom since Phil is here now?
Okay. Tom, do you want to go?
Okay. Yeah, let me make sure I'm unmuted. Phil, are you there?
Yeah, I'm here. Go ahead.
Okay. I was digging into the FT8 decode issue, and I sent you an email, but I don't know if you got it.
I'm way behind.
I think it's as simple as a missing file.
Okay, I'll go read it.
Yeah, there's a file called decode_FT8, and your comments indicate that it's something that you modified to pass a -F base frequency argument to.
Oh, yeah.
And you call
It's
that
another repository in my GitHub.
That file is nowhere anywhere. It's not in GitHub. None of the predecessors or the .cs or anything are there. There's no build targets. It's nowhere to be found.
Okay, it should be in my GitHub, a decode FT8.
It is
let me
not.
go check it. I'm using it, but I haven't built it for a few weeks. I'll go check.
Okay. Yeah, if you can include that in GitHub, I think that'll likely address the issue.
Any other comments, Tom?
Oh, that's it. That's all I've been working on this week. So back to the group.
Okay. Well, Franco, do you want to go next since I called on you?
Yeah, okay. So I've been working on two sides. One side I've been working on getting the data from Rob. Actually, Rob is here now. Rob Whisper Demon Grape server, the 10 sample per second files over to the Grape system managed by Bill. And Bill said this data set that I manually sent in via zip look good. So I'm preparing the script where everything that is there will be uploaded to the Grape system. So Nathaniel, you should be starting seeing some data coming from there. the first data set will be Michael Howans, because he already gave me the setup for that. And then I can discuss later with Rob. That's number one. Number two, I've been playing with my TRX Duo, been learning something about U-Boot, and I'm starting also to learn about Vivado, which is a tool to program the FPGA, and I've been playing with that. Tom, you're probably familiar with all the universe of things.
Only the Altera equivalent.
Oh, okay. But I have your sympathy, I guess. Back to net.
Very good. Next on the list, we have Jim, K4BSE. Go ahead, Jim.
Good evening. I've been working on a couple of presentations that are in my future. One of them to the club here on HamSci and what's going on. And Nathaniel, I appreciate very much the slides you sent me. I will definitely be using some of those with credit, of course. That's not until May, so I haven't finished pulling that together. I also got an invitation to do one for the club in the neighboring county next month on meters in the ham shack. It's one that I had developed several years ago, and I've already given to two clubs, and so I'm just trimming it in. I can't seem to give exactly the same talk twice. I've got to change it a little bit. And so that's interesting, and trying to get back in some digital RF stuff, plus continuing to keep the three HamSci experiments going. I think that's about it from here. Back to net K4BSE.
Okay. Next on the list, we have Michael, AA8K. Go ahead, Michael. You're muted. There you go.
It's hard working all these fancy computers. Greetings to everyone listening. And if you look at Detroit and Windsor, two cities across the river from each other, Windsor is south of Detroit and Detroit is north of Windsor.
Yes.
Back to you, Dave.
Very good. Next on the list, we have Dave, KD0EAG. Go ahead, Dave.
Oh, not a lot. Real exciting to report. Been working with the Grape folks, the Grape 2 people on the Grape 2 stuff, sorting out some kind of late questions that about the behavior of some of the code interfaces. That's probably my biggest undertaking these days, and also setting up timing stuff around. But all in all, staying busy, but nothing very exciting to report. Over to you.
Okay. Next on the list is David in one HAC. Go ahead, David.
Good evening, everyone. We continue to build out our AM Doppler system. Looking forward to the eclipse. We've got two students working on building our radios, trying to find sites. We're still looking for some sites out west. I will mention that Columbia, Missouri doesn't work for us, unfortunately.
Oh,
So it needs to be a little bit closer in. It's outside our ring of our skip ring or whatever you'd call it. I think one of our students' parents lives closer in to where we're looking for. But we're moving along on that to be complementary to all the other things that are going on. And it's been kind of cold here. It's been down to 0 at the lowest, but for what it's supposed to be this year, that's probably about 20 degrees more than it used to be. But we're now back up towards freezing, and I'll take it. So back to net.
okay. Next on the list is Dylan. Welcome back, Dylan. Dylan, are you there?
Yes, I am. How have you guys been?
Well, we've been good, I guess. We're just keep it going on week after week.
Yeah, that's good. Well, nothing much, just staying busy at work and preparing to go to the ham sci workshop and have fun with meeting plenty of hams and other people who like sciencey stuff. So that'll be fun. Um, really, I don't have anything else. Just checking in. So, send it back to net control.
Okay, very good. Next on the list, let's see. We have Jonathan, KC3EY. Go ahead, Jonathan.
Hi everybody. This week I contacted ProTempus, formerly the timing branch of Trimble. They were able to send me the documentation and firmware that I needed for the Trimble resolution SMT and SMTX GPS receivers, timing receivers. I also got an RMA rolling for the two Res SMT 360 GPS timing receivers that I use in the VLF system. The two I have failed. They both failed in the same way, and I want Trimble to, or I want ProTempus to do some investigation and see what's wrong. So I just have to ship that out, and hopefully they'll be able to tell me. Some other very exciting things is Graham from the UK, or from Canada. What he did was he installed VLFRX tools for use as a in the Grape application. I wanted to show you the email. This is the digital RF Grape plot that he generated at his location. And this is what he generated using VLFRX tools. One of the really exciting things is that not only does this generate really good data, it's very scriptable using shell scripting. And this is the first time that Grape data is actually GPS referenced, sample aligned and corrected, as well as time stamping. This is the first time that Grape data actually has that. Gwen Griffiths sent a couple messages on the group asking about the clock offset, or the error imparted by the sound card clock, and he needed something that was GPS referenced to do his data analysis, and he doesn't have it. This is a very good example of what he can actually use, and it is actually sample aligned and doesn't have any sound card clock error. Also, very exciting is a brand new release soon, VLFRX tools. It's been in development 14 years, and it will be version 0.9N. And one of the some of the features the program VT Spot can do, geomagnetic conjugate calculations. It incorporates the latest IGRF model, and it could calculate your conjugate locations. The and uh, the it has also have gotten updates for lightning location in that application, and one of the and the other update is um, meteor scatter. So that's when you use some sort of continuous wave signal, such as a beacon, to detect meteor scatter. So those signals actually scatter off of the ion trails for meteors. And Paul has updated his updated VLFRX tools for this purpose using, and what he does is he uses an RTL SDR, and this is his antenna and preamp. And what's exciting about this, and I think this is extremely beneficial for the group, particularly with the Clementine SDR application. So in a similar way that accurate timing is performed with a GPS pulse per second reference and a sound card, he also does this with an RTL SDR. And this is a schematic of what he does. So T1 is where the GPS pulse per second is input. T2 is a frequency reference from a U-Blocks MAT. That's the time pulse 2 output. So what it does is he uses a harmonic of that, and he sends it into the RF input of the RTL SDR, and he uses the GPS pulse per second, and he actually gates it in with a FET. So every 500 microseconds, that frequency reference is sent into the RF input. And so when the pulse per second is low, some of that frequency reference bleeds over into the RF input. And while it's bleeding over, what he does is he uses that to perform sample correction, and sample offset correction to give very accurate sample timing from an RTL SDR. And I believe that this is an excellent method that should be investigated for the Clementine SDR for proper correction and time stamping. Now you can use the Leo Bodnar, with the Clementine or the RX888 to get you an accurate frequency reference, but you don't have any time stamping facility. So this allows for time stamping facility, and it also allows for sample correction without the use of a Leo Bodnar. You could use a much cheaper U-Blocks, and without having to pay the $150 for the Bodnar. So I think this is a good method that probably should be investigated for the Clementine application. But this is an example of the timing output showing the correction. So this is the offset, and it's actually corrected to this is the value of the correction afterwards. So I was actually quite excited about this. This is the first time Paul actually did this. He uses a Minix PC for his meteor scatter and his VLFRX tools. This is an example of the output, the vertical lines here. are the actual meteor scatters. These curved lines are um, airplanes, because he's actually close to an airport. So I thought that was definitely worthy to mention to the group. That's all I have. Back to the net.
Well, very good. Thank you, Jonathan. Next on the list, we have KE2CNW. Go ahead. You're still muted. Any comments? Yes, not. Okay. Next on the list, we have Michael Howen. Go ahead, AC0G. Go ahead, Michael.
Good evening, everybody. I've been comparatively busy. That is, compared to other weeks and so on. I somehow messed up a Metis card in an open HDSDR radio and HPSDR. So I found a USB blaster, and I'm trying to screw up my courage to see if I can talk to the FPGA. Don't know if that's going to work or not, if I can recover it. I've been with Rob's help setting up an alternative computer to take up to Fargo. I have magnetometer data regularly uploading from Fargo and from here. The system I have here for Whisper Demon is collecting a decent amount of data, and we're using that to see if we can upload concurrent channel data. Franco's working on a script for that to Bill's server at the University of Alabama. And I've also been fiddling around today trying to see if there's some ways to visualize the difference in the data we're gathering between WWV and WWVH. And we can talk about that a little bit later, but WWV does publish a tone schedule that specifies what tones each of those two stations broadcast, not just on the minute, or sorry, not just on the hour, but on a per minute basis. So if you selectively filter, then you can see traces that correspond to the individual stations in the single wave file, which may be of interest. I think Nathaniel had mentioned something about that potentially being useful. And that's it. Back to net.
Well, very good. And next on the list is Phil, K9Q. Go ahead, Phil.
Hi, hi, Dave. Group. I haven't been all that busy. I'm still shaking off whatever it is I got earlier this month. I think a lot of people are doing that. But I'm here. I'm conscious. So go ahead.
Okay. And let's see. Next on the list is Rob, AI6VN.
Good evening, everyone. I've been busy installing and configuring now I think 14 Whisper Demon stations, which are contributing now, uploading the 10 hertz WWD wave files to a central server. So each of these stations is uploading wave files for all 10 bands, if they can receive them, WWV-B through WWV-25 and the 3 CHU stations. So there are, each station is uploading about 30 megabytes of wave files every 24 hours. So there's a wealth of wave files now. And with Franco's help and help from Michael, we're in the process of seeing how we can, and Bill's help, getting that data into the digital RF database that Bill maintains. So I think Franco has taken the lead in that process. I've been so busy just getting all of these stations configured and observing various problems. I think that the major problem I have actually would be helped by Phil. Now that I'm going to a lot of sites, I'm beginning to observe overload conditions on the 888. So if I set the gain at these stations for daytime normal sensitivity, I come back the next day and there's a huge period of time when there's been overloads. So I think it would be really good, Phil, if when you have time, at least my priority would be to ask you to look into the AGC, adding AGC in a way that helps, doesn't eliminate our ability to measure the absolute background noise levels.
Well, here's your thing. You want AGC, but you don't want AGC. I can't figure out what you want.
What we'd want is we'd want you to look at the overload count. If there's overload count is significant and the RF input level is too high, lower the gain, the front end gain, so that the overloads don't happen, and at the same time adjust your demodulation gain so that the absolute signal level remains the same. In other
Okay,
words,
that I already do. I mean, that's what the RF gain static
I
set fig file already does. Okay.
I don't then I don't understand why when we turn on AGC, the background noise levels
No,
never change.
that's a different AGC. When you set the AGC in the channel file, that is a true AGC, just like you have in a conventional sideband receiver. The gain setting in the global section or the hardware section in the config file is, which you're probably talking about, that's a static setting right now. And it's there just to keep the A to D converter within its range, and it's compensated for by a digital loss immediately following the A to D converter. So the analog gain is canceled out by a digital loss.
So if we are you currently adjust? I mean, you have no way to, though. The AGC that we set is, if I turn on AGC, will you adjust the RF gain amplifier?
No, they're two totally different things. As I've
Okay.
explained, there's an AGC at the very end, which is what the AGC command does, and the gain parameter can do manually in the per channel definitions. And then there is the front end analog gain. It's strictly analog that controls what the RS888 puts in front of the ADD converter. And that is taken out by a digital loss that immediately follows the ADD converter and affects all channels.
So is there an AGC gain setting that I've missed?
Oh, no, the front end right now with the RS888, that front end gain setting is only manual.
Yeah, well, I think we need you to control it. Look at the okay. Look at the
problem is, of
levels
course, I
and
mean,
adjust it.
how should the algorithm work? I mean, if I see a burst of overloads, I can knock the gain down, but then you're going to complain that the gain is too low and the noise figure is too high.
Well, I think what you should do is
stay that way for hours.
Yeah. Well, I would sample every minute. Look at the count for the last minute. If the count is unreasonable, if there's more than 0.01% of the samples are full range, then adjust the gain down. And
okay, so what you're saying is you want a 1 minute time constant on this front end AGC.
Yes,
okay.
If you could put a 1 minute time constant, I think we'd be very happy with that. That would
Okay,
address.
should it be a boxcar function? Should it be fast attack exponential decay? I mean, you got to tell me what you want.
I think we should just start with a boxcar right now. Nobody's listening to this. This is, this AGC is not to help a human hearing ability of the. This is to this is to
the only
protect
problem is because I'm controlling an analog amplifier, there's going to be some skew, and when I apply the digital gain, the digital attenuator to account for that, there's going to be a glitch because of timing.
There's always bursts of noise, and this isn't going to nothing is perfect.
It's going to be a burst of gain or whatever.
Yeah. Okay. Well,
right.
if you could incorporate that and let me know when it's checked in, then I can test it out at a number of sites. I'll be able to see how I can compare it at some sites. I can compare the fixed gain setting to your new code and learn, and validate that it's working. That would
What
be
I sus-
really helpful.
What I suspect you're getting is, because most of the time you look at it, the input is nice and Gaussian. What you're getting are occasional bursts of strong local interference, which for all I know could be local lightning hits, right? And do you
I
really
don't, I
want
don't,
to?
I don't think so. I mean, we're looking if local lightning hits are brief events. I mean, they don't
Well, yeah,
these
but that's
I'm
enough.
saying I'm seeing 1% of the samples over a 24-hour period are overloads. That's
Well, I don't know how
that's
many lightning storms you've had lately.
this is
Lightning is actually not that brief.
well, on the Kiwis, I don't see this problem. So the Kiwis, I can set the fixed gain on the Kiwis, and we don't have overloads. So I think that there's a mechanism in the Kiwi that does what we're describing, here, that does address the problem.
Well,
And
find out what that mechanism it is on the Kiwi, because I don't know what it is. I mean, for all I know, it's a fixed gain. It's just different than mine.
I think I think that what you're proposing to do, just a boxcar function, the simplest thing for you to implement would be the place to start. I don't think there's any way to predict what will work well. I think we can only experiment. And
Okay. All
I
right.
don't want, okay, and just since as long as I can turn it on and off in the config file and reboot the machine, we can always go back to the way it is now.
All right.
You don't sound very happy.
No, I'm not, because we've been going around on this for months.
Well, we now have 14, 15 sites that are using this.
Yeah.
And
I mean, if you could record this stuff and go back and actually listen to a channel during one of these events, that would be very helpful to characterize what the nature of the noise is. It might be a nearby transmitter that's on only for short periods of time. It might be lightning strikes. It could be any number of things.
And well, these KPH and KFS don't have nearby transmitters, so they're.
Well, you don't. How do you know that? I mean, somebody might be carrying a radio. You don't know.
Well,
be a car drive with a noise ignition driving past the antenna array.
Well, come out and visit KPH with us, and you'll see what the nearest car that drives by is half a mile away because they locked the gate. So it's
my point is that avoiding all ADD overloads is not always what you want to do.
I'm not trying to overload. I'm not trying to by any means but I think you could.
How many are acceptable? You're saying what you got is too many, but okay, how many are acceptable?
Well, when your DBFS value goes up to -8 from the target -15, that's okay. That's what I'm saying.
Something then is not Gaussian, right?
I think
that means your source is not. Something is making it not Gaussian. What is that?
It is called the sun. And the sun, okay. And what happens is that these happen almost always at all sites, happen at gray line times, 5 a.m. to 6 to 7 or 4 a.m. to 7 a.m. Any receive site will get this tremendous burst of very strong signals, much stronger than it would see otherwise. And
that's useful to know.
And that is what we're really trying to protect against, is these 1 or 2 hours. I do log for the Kiwis, for example. I do log every 2 minutes, log the number of overload events reported by the Kiwis. So I have the Kiwi log files from these sites showing every 2 minutes how many overload events there were. And those logs, and from those logs, I can tell you, because that those overload events at almost all the sites I've looked at have been at between 5 and 7 a.m. typically. It surprises me it doesn't happen in the evening at sunset. I don't really understand that, haven't really understood that phenomenon. It is similar, but not nearly as intense. The morning propagation conditions are extraordinarily good at the sites that I'm familiar with. And I don't.
Should we finish the net first, and then we can discuss that?
Yeah.
Sorry.
We
Should
still
we finish
have
the net call first, and then we can discuss this topic?
Yeah, I'm sorry. Yes, of course. Anyway,
Okay.
we might. Yeah. Sorry to wander
So-
off. Anyway, that's what I've been doing. It's a-
Okay. The last person on the list is Tao. Tao, you have any comments? He's muted.
I drove him away, I'm afraid.
Yeah, I don't know what happened. So we've had two new people and neither one are willing to say anything. So
Well,
anyway, well, at that point, we're open for general discussion. And
I missed Franco. I didn't hear what Franco had to say.
Franco was earlier.
Yeah.
I do want to mention on this discussion that Rob and Phil were taking, you know, these phenomenons may be of interest to Nathaniel as a scientific area of study. What do you think, Nathaniel?
I think it's very possible.
Yeah, I for the Kiwis, I log along with each. I log. Yes, I log along with each spot. I log the number of overload events during the recording of that spot. That's part of the extended spot database. Of course, for all of the spots in 1 2 meter, 2 minute long cycle, they all get the same overload count. I mean, the overload count is since it's a wideband, direct conversion SDR, every spot is coming, there's no filtering ahead of them. So they all have the same spot count with them. I just haven't had time to add Phil's. Phil has a control mode, which would allow me to read the overload count values from 9Q, and I will put those. I will be adding one of the things to-do list is to add Phil's spot count values into the spots, so that we have an idea of the quality of the receive environment during that when that spot was being decoded. So there's more information to be added to extracted from Phil's recordings and his noise levels, which is a little bit a problem, only a small problem for me, because I think I prefer to have add Phil's noise level calculations as a third noise metric for each spot, rather than replace one of the existing Kiwi noise level measurements. So I need to talk to Gwen about that. We'd have to modify the database, but I think and this is, anyway, it's a nightmare for me, program wise, to add another field into the database. It's trivial to add the field in the database, but the way that the spot data gets communicated through the chain of transmission inside of Whisper Daemon, it's not JSON data where each field is identified. So there are all of these fixed width fields. It's a mess dealing with them. So that's why I haven't. That's why I really haven't added Phil's data. The easiest thing would be to replace something, but then we lose the reference, a way to compare Phil's measurements with the ones we're making from the Kiwis, and we'd still be making those noise level measurements because they come out of the WAV files, and of course we get WAV files from Phil. So anyway.
So we also had a question. You had a question for Franco, right? Just to repeat what he's been up to.
Yeah, I think Rob wants to know what I was telling you, so I'm just gonna be quick and give an executive summary here. So basically, I was able to create the data set on the grape from Michael's data. I have both the Python part, which is the part that convert from WAV files to digital ref with all the metadata done, and I already have a part of the script, a shell script, which Rob then I will show you what it does, to actually do all the, all the loop around the WAV files, the flag file we talked about and so on. The last part that I'm missing, which is probably the trickier one, is how to upload it to the Grape servers. The reason is because it sounds like from the documentation that Bill Engel can send me earlier, I can send the link later when I go back to the computer, they use a program called LFTP, which I think does FTPS, i.e. FTP over SSL. And I don't think that you can use rsync, and so I may need to install also LFTP on that Grape server. I don't know yet. I just have Michael promised. He probably already sent it to me, but I haven't checked my email. The script. So once I take a look at the actual script, I have much more information. So tomorrow morning or tomorrow after work, I should be able to do the uploads.
Okay, you're welcome to, yeah, you're welcome. That's great. And you're welcome to install, any new programs on that server. I've been using rsync to upload
Yeah, but it's a different protocol. rsync is based on SFTP or
yes,
SSH.
yeah,
This one is based on FTPS.
Yes, that's fine. I mean, whichever it's, I don't really care. It just,
Yeah.
I chose this case to use rsync to do the uploads from the clients into the Whisper Daemon one database. It also helped me, but I didn't have to. I really didn't want to have to issue out have people have a user account on the Whisper Daemon 3 server. So I'd rather use our.
Speaking of accounts, that's topic number 2 I forgot to mention. Bill also said that for each grape-like, I would call it, station, we need to create a register on Bill's site. I don't know if you saw the instruction. I can send it to you.
Yeah.
So Michael's is already there, but we need, user IDs, station IDs, and access token for each of them. So if you can make them, and then we can put them in a file, in a credential file, protected to use those.
Would it make sense for me to create and store those on at the individual sites and communicate them in a file that is uploaded along with the WAV files, so that that we don't have, so that they don't have this locality of reference problem where we have multiple copies of things that could get out of sync. So my thought would be, I'd put a file in, like I put it into the whisperdemon.conf file where everything else is. Put in this, and then the Whisper would extract that grape ID and put it into a small little text file that was in the among those 24-hour WAV files that are uploaded, and then your code could read that file and learn about the ID, digital RFID from there, and then use that to go and access Bill's server. Does that make sense?
There's no way of getting around. There's no way of getting around having somebody, whether it's you or the individual station operator. I don't think there's any way to get around this. Logging in on Bill's server and creating a station, creating an instrument, getting the station ID, and getting a token.
Yeah,
that process has just got to happen.
That's not hard. That's easy. I can do that, and I have remote access to all these sites, so I can go and put that information once I obtain it. I'll put it into the Whisper Daemon configuration file, and then Whisper Daemon will communicate it up through this file, and I'll simple text file, probably 2 lines in it.
The other thing, Franco, is that you have to download the public key in order for LFTP to work. So if you do a quick SSH to Bill's server, even though it will not drop you into a shell, it will load his server's public key on grape.whisperdemon.org, and that will enable the secure socket LFTP to occur. I got bit by that until Bill told me I had to go through that step to
I'll
the
yeah, I'll
public
take
key.
a look at the script and what you send me, and then I'll work on that and try that.
That's great. Thanks, guys. I really appreciate your
Yeah,
help on this.
yeah.
That's
The
great.
one thing, Rob, is since these are actually credentials, probably the least amount of copies around we have, the better, you know, because I don't know if you want to keep all this information copied 25 times and so on. So maybe we can even not put them on the side, but put them centrally on the Whisper Daemon and just use them from there.
Well,
Makes
we could do it that way. If that then the advantage I thought of keeping it, putting it at the the client sites, whisperdemon.conf is then we don't have to administer it each time. If you could have any user via 888, set it up, run WhisperDemon, get their credentials, put it in their whisperdemon.conf, and they would be part of our network. Otherwise, they would have to communicate that stuff to us, and you or I would have to go in and put it into a file on the server. Either way, I guess works. It's just
no, I see your point.
I'll do whatever either way, but I do have very easy mechanisms to read variables out of the whisperdemon.conf file. So, and that way, if well, no. Anyway, that was the way I was thinking. So, anyway, I will do that. I think we had agreed on a handshake mechanism, where I will also tell you, we'll have a client tell you when it's finished uploading all of the data it has for a date. I've just brought on a second, while we're talking, I'm bringing up a receiver at Glen Elmore's N6GN, which is a second line of sight to WWV. And he has about 20 days of WWV recordings cached, and it's taking hours for it to create the WAV files. I mean, this WAV file creation process is amazingly slow. So it's ponderous, almost in a sense deliberately so, because I run it on one CPU core, and that way it doesn't overwhelm and interfere with the rest of the Whisper Daemon spot decoding and so on. Okay, anyway, that's great. I'll keep in communication, Franco. If you need anything from me, I'll let you know once you'll start seeing these appear. I'll have to update the Whisper Daemon software, add that feature to communicate when it's done, and to communicate the ID that I get from Bill. And there is an ID for KFS that I got from him, but I don't know. I'll have to search for it.
I can use Michael's for this first test, you know, I can do Michael's site, you know, since I have his credential, and once we officialize the way to do it, we can do it. What are you showing there, Michael?
This is the discriminator. Rob sort of gave me some pointers on how to try to filter some of these or the IQ files that Whisper Daemon stores. Behind it, you can see the tone schedule for WWV. Can you see that? So minute 0 down to minute 59. WWV broadcasts a 8.8 second, 800 millisecond, 1000 hertz tone. WWVH does the same at 1200 hertz. And then each minute of the hour, they'll broadcast these tones. And so what I did was filter for these separate tones in each minute, which, you know, Whisper Daemon conveniently saves the data as. And instead of just printing what the tones were, I actually matched what the tones were with what we expected over here, so that these data
I don't see that part of it. I don't see I only see one graph. So is there?
I beg your pardon. There's I guess I have to share this independently. to,
You can share a
How do
whole
I-
desktop. If you can share your whole desktop as an alternative.
how can I do that?
You have to stop sharing and then go back in and select the desktop as
Okay.
the option when you come back in.
Share screen, full desktop.
They
share.
may make it maybe advanced because they've kind
You
of
see this?
Yes. Now.
Yes, yeah.
Yep.
This is the tone schedule. So these are the minutes down to 59. So sometimes WWV broadcasts at 4 past the hour. WWV broadcasts 500 hertz. WWVH does 600. But then the next minute they swap. And then the next minute they swap. And then the next minute
Right.
they swap. And then there's 2 minutes of silence or 3 minutes of silence for both of them. And then they do this swapping business again.
Yeah, except
So
8 minutes after is not silence. It's our test tone. The scientific
Well,
test tone.
correct. That's right. And there's another combined episode of silence here at minute 14 and 15, and one at 18 past the hour, one at the bottom of the hour, 29 and 30. And if I get that graph back up.
Yeah, one thing to
Yeah.
be aware of, the WWV broadcasts the test tone at 8 minutes past and WWVH at 48 minutes past.
Yeah, but
Right,
that's different from what he's doing here.
Well, it might be something he can discriminate on as well.
Yeah. But this is looking really good, Michael.
This is then, if you look at here, here's a point of common silence just before the 30 minutes. This is sort of a sniff test to see that this is actually working. This is the 2 minutes just before the bottom of the hour where neither station broadcasts a tone and their silence. There's another gap, a silent point out here.
Technically not silence. There's a station announcement in there.
Well, what I mean is silent in terms of this tone,
The
which
tone,
I'm trying to
yes.
discriminate.
Correct.
Because I'm using the tones as a discriminator. Am I hearing WWVH or am I hearing WWV? So anyway,
the voice
this is
probably
sort of
will have some components there, but you won't pick up much.
I would expect so. Well, I applied a
Remember,
fairly
I've done
narrow
a
filter.
WWV emulator that you guys can use as a sort of reference for this.
Well, and this is my first sort of pass through it, and I'm not quite sure what form the data would be in that would most meet Nathaniel's needs or needs in particular. I think there's probably
I
some
think this is
mechanisms
a
of
very
graphing
clever. I think this is a very clever way of looking at it. I like how you have mapped out the 2 different frequencies as a function of time and just combined it into one to potentially give us a metric of seeing how strong the 2 stations are. So I think this is I like where you're going with this.
Yeah, Michael, are you able to get amplitudes off of the time ticks?
That's what this is, right? This is the magnitude.
That's what this is. These are magnitudes of just.
Was that time tick, or I thought this was the tones themselves?
Well, it's
you're doing
I
both.
have not. They're all together. It's really just the aggregate in that second. I could get
just wondering.
Much more finely granulated. These second ticks are only 5 milliseconds. The tone at the top of the hour is 800 milliseconds.
But if you can discriminate those, it's very helpful because they're constant. You know exactly what they are. You know, it's 1,000 hertz on one and 1,200 hertz on the other.
Yeah.
I can
using...
when I'm listening to the stations, I can my ear can discriminate which tick is coming through.
Yeah.
As well as, you know, I hear the different.
They're designed to be orthogonal over short intervals.
WWV. I can also hear the time difference between the ticks, which is really fascinating. They're several milliseconds apart. I'm in New Hampshire, and right now, by the way, 15 megahertz, I'm hearing WWVH, but not WWV.
Are you using the 1,000 and 1,200 hertz tones at all, or are you just using the 500 and 600s here?
I'm using all 1, 2, 3, 4, 5 tones.
Okay.
I'm using every single one of these tones. You know, at the top of the hour is at 1,000 and 1,200. And then at the at the first and second minute, there's the 600 alternating with the A 440.
Right.
And then for the rest of the time, it's 500 and 600. So
Yeah.
it's just marching through minute by minute and doing the FFT on for about 20 hertz around that bandwidth and
Right.
measuring a magnitude. And then I'm just correlating it with what this is expected, which
Yeah.
one of the stations it's expected for.
So you've essentially set up a filter for each of these tones, and you're then seeing the amplitude coming
effect,
out of each one?
Yeah.
So, and the filters are fast enough so you can see the time ticks coming through, the seconds?
I haven't tried to zero it down to the sub-second part.
Okay.
No.
Yeah, that was my
What you
question.
really want to do here is correlate for the composite waveform for both. And my emulator will let you do that. It can generate either WWV or WWVH program audio. And you just do a correlation. You use an FFT, very much like the fast correlator I'm doing with my receiver, except here you're actually correlating two complex waveforms. And then you have to decide what interval do you want to integrate over, because, you know, propagation is going to be changing. Doppler shift is going to be changing. And in my emulator, you can just turn off the voice announcements because they're not going to match. And you look at the tones and the clicks. Both of them are transmitting the 100 hertz subtone, which is actually going to be the same, except for the delay. So I'm not sure that would help you, but you can either turn that on or turn it off. But take a look at my emulator. It's on GitHub, WWVSim, under KN9Q.
Cool.
Where are you, you're running this one at your station?
Yeah.
Michael, yeah. It'll be interesting too to see if when you get it running, if you can get running over at KPH or some of the other stations, and where you typically hear WWVH more often, and see if your graphs flip for those other stations.
Right. These graphs would look very different station to station,
Yeah.
depending on location. I mean, yeah.
Yeah. I think what you're doing here, I think is extremely valuable.
What time resolution do you need, Nathaniel? I mean, there's an obvious trade-off here between time resolution and sensitivity.
As I keep telling people, I think as good of a time resolution as you can give us. I think what's
Well, that doesn't answer the question, right? Because the better the time resolution, the worse the, you know.
No, it does answer the question, because it's, if you can reliably tell me what the answer is on a, millisecond or microsecond basis, then I'll take it. But if we can't reliably tell on that level, then
Well, the best you can do there is the intervals over which the two tones are orthogonal.
Yes. So I think,
that's actually pretty brief.
So a very I really think, if we had the answer on a 1 minute cadence or even a 5 minute cadence, I think that would be very useful.
Yeah, I don't think that
pretty long integration time. It'll be very sensitive.
Yeah. But I think having that is a very usable, if we can go down to a lower integration time, great. But I think if we just have that information on a 1 minute cadence, that's better than what we have now, which is no information.
Okay, if you're going to integrate over that long a period of time, now you have to look at the behavior of the AM modulator and the fact you're getting carriers from both of them that you can't separate. And if you look at just the side bands and ignore the carriers, the problem there is the sideband phases are going to be unknown without the carriers.
Right.
So you're going to get two sidebands from each one that are going to be in some random phase relationship to each other. All right. Now you can reconstruct a carrier from that, but now you have the squaring laws problem, right? You take two sidebands and you reconstruct the carrier while ignoring the actual transmitted carrier, because they, you don't know which one you're seeing. Now you have the classic problem of squaring loss, and that you don't know. You know what I'm getting into. It's a classic relation problem when you have.
If you treat it as a double sideband suppressed carrier signal.
Well, that's what I just said. I mean, if it is, but now you have to reconstruct the carrier. If you're not going to use their carrier, carrier. You have to
Yeah, it's called
reconstruct the carrier.
synchronous
One.
demodulation.
Right, right. But the problem with that is there if the signals are very weak to begin with, I mean you run into this problem. You're demodulating BPSK in very low signal noise ratios.
Okay.
Right.
Well, one
It's called
big
problem is
advantage
called
here is
square
you know
loss.
exactly what the carrier frequency is,
You know the frequency, but you don't know
except
the
for
phase.
a little bit of Doppler shift.
But you don't know the phase. Right. You're gonna get two sets of sideband. Let's say you got WWV and WWVH are transmitting 500, 600 hertz.
Right.
If you could demodulate that with an envelope detector, but now you've got the nonlinearity, the threshold effect of the envelope detector, because which carrier are you using? Right, you're going to be using the phase of the two.
Can't you also just take the FFT over some certain amount of time and just look for the 500 hertz tone and the 600 hertz
Yeah,
tone?
then it becomes a non-coherent demodulator. I mean,
Right.
if that's okay, then fine.
Yeah, I think that's okay. I mean, the way I would use the information right now is we're looking at the Doppler shift on the carriers, and like I'm interested in either the traveling ionospheric disturbances that we're seeing there, or I'm interested in the dawn signatures, the dusk signatures, or the eclipse signatures. And I'd like to have some sort of reasonable confidence to say, okay, when I'm looking at this particular carrier, I'm reasonably confident that this is coming from WWV primarily and not WWVH or the other way around.
All right.
And
All right.
so if I
very
even
often you're
have,
going to see both, you know.
yes, but
Yeah.
but if I had something that said, okay, it looks like WWV is coming in, 80%, stronger than, WWVH is, then that I think gives us a higher probability that the carrier that we're seeing in the features we're seeing are more likely from WWV.
Okay.
Yeah, but I'm not quite clear what the problem is here, because you could just take each of the side bands, take an amplitude of each, and then add them together.
If non-coherent detection is what you want, that's fine.
Yeah, I mean,
yeah.
I
just
you only
non-coherent.
have one sideband.
I just want some number that as a function of time, even if it's on like a 1 minute basis, at least some way of estimating, are we more likely hearing WWV right now, or are we more likely hearing WWVH, or in relative proportion to each other?
Well, that works in
More likely
most of the
doesn't seem to be
time,
the right
where
question.
by decoding these various known tones, you can tell that it's mostly WWV, mostly WWVH.
Right.
But I will say there are a lot of times I've got them almost equal amplitude.
Right.
And then that's useful to know too.
Right.
Yeah.
But the thing is that if you get rid of the carrier, don't even worry about that. You've got two sidebands that you can suppress noise with.
Right.
And just demodulate each one and sum them together.
But what we're
yeah.
interested from the science point of view here, at least what the GRAPE project is, that the thing we're focusing on right now is the behavior of the carrier, the Doppler shifts on the carrier. So
but you don't know what the carriers are.
Well, you know that the carrier is coming along with the sidebands, but if you're looking for an accurate
what I'm saying
amplitude
is
and
what I'm saying is
relative
the
measure
carrier,
of the two, use the sidebands.
What I'm saying is the carrier, even though it's the majority of the power output of the station, it's a shame to waste it. The problem is
but you
that
can't discriminate
doesn't
the
really tell you what you
carrier.
want to know. You probably should.
They're right on
That's
top
right.
of one another.
That's right.
That's the problem.
That's right.
You're getting the
look at
Doppler
sideband.
shift off the carrier, but you get
can
the
also get the
amplitude
Doppler shift off of. You can also get the
information off
Doppler
the
shift off
sideband.
the sidebands.
But you can't get it continuously off of those sidebands.
Well, as long as
Well,
they're
you
there.
can't get it off the carrier. You have no idea.
I don't think that's entirely true. I think you do have some idea.
No, you can't tell which carrier you're getting. You have no idea.
That's not true. I think if you look at the sidebands, like if the WWV magnitude is 10 or 100 times stronger than the WWVH magnitude on the sidebands, then I think it's more likely that you'd be getting the WWV carrier.
That's correct. No, I'm not
Right. And
disagreeing with
that's
that.
what
I'm saying
that's
to
what I'm
determine
saying.
which carrier you're getting,
Yeah.
use the sidebands.
Yeah, I know that's exactly what
And
I'm
you
saying. And
right.
and
Much
And
that's
of
you
the
don't
time, at least
need
not here, you're going to hear the two of them together, and they're not going to be 100 times apart. They're going to be much closer much of the time.
well,
That's
I
what I
think
hear here in California.
well in California, yes,
yeah,
but that's not
California,
here
you
on the
definitely
East
do.
Coast.
I mean,
And so what I want a metric so that when we we don't really know. You know what's you have your intuition from California. I have my
Uh,
intuition from
no,
Pennsylvania, but we don't really know. We haven't really looked at this across the whole US.
yeah. Now
So
here's another part to
we
this.
don't actually know which one is
Yeah.
going to come up stronger in
Well,
each place.
except
And
that
that's why we need to do this.
now if you get the Doppler shift off of the sidebands,
Hmm.
then you do know which one you're getting
Yes, but
right.
at the
yes,
same time.
yes, but you don't get the continuous, you don't have a continuous sideband telling you. You just have these.
Get it for 45 seconds at most minutes.
But that tells you which one is coming in.
You can directly measure.
And the thing is that you may not have it continuous, but you can get for much of the hour, if you're getting Doppler shifts off of the individual tones,
Mhm.
you know exactly which one it is. And in fact, you can tell, you can get
So
it off of
I
both
think this
stations at the same
I
time.
think this goes back to what I
Right.
originally said. What I originally said is really to make this work, like what we should really be doing is capturing the spectrum that covers both the carrier and up to the 1200 hertz, or a little beyond the 1200 hertz tones. And if we
You want to
capture
get up to, just to be complete, you want to actually pick up 1500 because that's the top of the hour tone.
Okay. But I mean, we also have to strike this balance because every time I start saying, okay, we're gonna collect more bandwidth, I have people like Bill Engelke saying, where are we gonna store all of this data? How are we gonna get it through the bandwidth? So there's constantly a fight between the people who want more bandwidth and the people who don't. So
I don't
so
really understand where this freak out over the bandwidth is because, to get, you want
okay.
like say 2
So
kilohertz
but
bandwidth.
my point is, to really do this right, we have to capture the full spectrum that covers these tones, whether you pick the 1200 hertz tone or the 1500 hertz tone, or you can even say, let's make sure we capture the entire, phone, the voice sidebands too, so we can hear whether the guy is talking or the girl is talking. Somewhere, we have to you capture that raw spectrum, you save it to disk somewhere, and then you can post process this any way from Sunday you want to try
Yeah.
and figure out which one you're hearing. And then
Well,
that's the optimal
You're worried
situation.
about bits. You reduce it in real time as you're receiving it. That's not a problem.
yeah,
Well,
that's the other thing. You can be doing the decoding in real time,
yeah,
and then
and
you
so
just store the relative amplitude.
yeah, well, that's what I said too. So I said that's the other approach is, okay, we only keep the 10 hertz around the carrier, so we get the carrier Doppler shifts, and then yes, in real time we save whether you're hearing, more WWV or WWVH. I think that's exactly what Michael's trying to do here. So, or you can strip off just those couple tones and save the spectrum for those. So I think there's a lot of different ways to do this. But regardless of which way we pick, I think any way that we pick is better doing right now with the grape, which is right now with the grape, all we are doing is saving the carrier. And all we're doing right now is saving like, plus or minus 5 hertz around the carrier, which gives us absolutely zero information about whether we're hearing WWV or WWVH.
Oh,
So
except on 25 megahertz.
well, yes, but any of these approaches I think is better and more useful than what we're doing right now. So just like I also believe that with our original version of the grape, where you're just saving a single frequency as a function of time, as I think the plus or minus 5 hertz spectrum around the carrier is so much better than the original approach. for what I think is a minimal amount of additional data collection. I mean, we didn't even have to change the hardware on the grape. It was purely a software update that was able to be done in, Bill had that up and running, within weeks of talking about it. So, yeah.
So here's one option. I mean, in order to get these other tones, you don't need to capture or upload, record to the global database a full 1500 hertz spectrum. You have a set of 4 or 8 specific tones. Now, couldn't you just take those and translate those tones down to lower frequencies, and so you have compress I don't really mean compress the frequency range, but to translate the higher frequency tones, 800 translated down to 12 hertz, and 1200 translated down to 16 hertz, and so on. You'd lose the temporal resolution, of course, because you only have 18 cycles per.
Well, yes, I that could be done also. I suggest, at least for right now, we only have what, this is the end of January, so February, March, April.
Yeah.
We have maybe 3 months until the eclipse. I say for right now, we just collect the, 1200, make sure we can collect the 1200 or the 1500 hertz tones just in their entirety, at least through the eclipse. We have it's not gonna, I don't think you'll break the bank in terms of data storage.
I don't think I think no, it will. I mean, the 24-hour, okay, just a 1 minute long. Now this is 16 kilosamples, all right?
Mm-hmm.
Okay, 1 minute long, 16 kilosamples is 5.6 gigabytes of data.
1 minute long?
1 minute long. I'm sorry. No, I'm sorry. The 24 hour 24 hours of 16 kilosamples. I'm sorry. So 24 hours of wave files of 16 kilosample wave files. The IQ wave files is 5.6 gigabytes.
Okay.
Per band. Per
Okay.
band. Okay. So that's what I'm doing. The Whisper Demon sites are actually caching and storing those uncompressed. They are available. So they're sitting there. But of course, even those sites with terabyte drives don't have enough space to save more than 10 days worth of data. So I round robin the data. So if you were to tell me, last week, 7 days ago, I'd really like to get the full spectrum, the full. I could give it to you from KPH right now.
Mm-hmm.
But if you were asking me for that December 31st event, I don't have it. It's gone.
Okay.
So
I have it.
Yes.
Yeah.
Just another quick thought on this is that you might look into various data compression algorithms, because
we do that, Dave. We compress this using FLAC.
These are single tones. They are extremely compressible.
Yeah, but these are FLAC compressed, which is lossless compression. It compresses noise, right? By about 50%. And of course, if you have a pure tone, compression ratios can go to 95%.
Exactly.
But the reality is that right now with these recordings from WWV, compression ratios are about 50%. So that's how they're stored on the Whisper Demon servers. I take the wave files and I compress them using FLAC, which is, I think, the best at doing wave file compressing, and I store those into a non-volatile storage. And when we process them, to prepare the 24-hour wave files, I have FLAC decompress the 24 hours of a band into shared memory RAM disk, and then I have a SOX run across the 24-hour, the 5.6 gigabyte 24-hour recording, and create the 3.8 megabyte. I think it is the 3.8 megabyte 24-hour 10 hertz wave file. That's the result. but I save those compressed FLAC files as long as I can. And but you know, if I had, yeah, okay, attach a 4 terabyte drive, and then we have maybe keep a month of them. But but I don't think you want to have a central server that's going to be storing all that stuff, even in compressed form, because we're talking about you know, a huge volume of data, petabytes of data.
So I think what, again, I think what Michael Howland's doing is a very useful thing. I think that approach of looking at it and trying to say, okay, on a minute by minute basis, what's the relative magnitude that we're hearing WWV or WWVH in the sidebands? And then in post processing, you know, you save that information along with our 10 10
10
samples
hertz,
per second, the 10 hertz bandwidth.
yeah.
You know, you save that. And is it perfect? It's not perfect. Does it get us all the information we'd ever want to have? Of course not. But it's way better than what we have right now. And I think it will be useful, because I think in looking at the data after the fact, if we look at the grape data, I think if we look at stations from California and we see, oh, look, you know, they're seeing equal magnitude of WWV and WWVH in the sidebands. Then when we look at the carrier observations, you know, we're going to interpret that or look at that differently than if we look at an East Coast station where it's just primarily WWV. And
Well, that's fine. And my
Yeah.
intention was would take what Michael's work and incorporate it into Whisper Daemon, so it runs on the individual servers.
Yes.
We don't burden the central repository with the processing.
Yeah,
because it's all.
I think that would be really, really good.
Okay, well, that's
and the way, and you know, I appreciate all of like the fine detail to attention to trying to figure out, you know, to really sort this out in extreme detail. But the majority of my scientific work so far has been I've taken you know, just raw RBN, WhisperNet, and PSK reporter spots. I've just been looking at whether you see them or you don't. I haven't been looking at amplitudes. I haven't been looking at frequency shifts. Then I'd look at like super darn observations. Again, there's so much error in these things, and yet I'm still able to get useful information by looking for certain patterns. So even if we don't have this perfect, having some additional information that gives us some sort of idea whether it's, you know, WWV or WWVH, I think that's going to be really valuable.
Yeah, well, it's I mean, the other attributes is the ones I mentioned earlier for the spots is to know about overload data. But if Phil implements the AGC as we described, we won't have any serious significant overloads. It'll be taken care of, so we can trust it.
Yeah. And I mean, and all of these things, like, you know, as we look at it with time, we might come up with a more clever, better algorithm for sorting out the different things, but I think having this, like, I'm very curious, Michael, even if you just take your algorithm that you have right now and you put it on a number of different stations, how does it look across the different stations? Does it, you know, is our index of is our hypothesis correct that if you stick it on a California station, it's going to be more or less the same for both? So I think it's a really useful, and maybe it can be improved by looking at the 1,000 and 1,200 hertz tones. Maybe that doesn't make a big difference. Maybe you get the same information. It's hard to tell right now. And I think systematically, like if we just have that information, you know, I think it'd be interesting to like take a map of all the grape stations and, you know, color code them based on like average WWV to WWVH ratio. You can take one magnitude, you know, divide it by the other, and you can, you know, get relative values of which ones they see more often on average, and we could do it as a function of local time. So you could see how a particular station sees it, you know, throughout the day. And you could do it as a function of local time and as a function of frequency. And I think we'll see some really interesting patterns arise just from that really simple approach to getting that information.
Well,
I'll keep
Michael,
working
you've
on
got you've got the rest of your year's work set out for you there. So, anyway,
That's a good learning experience for me. I'm
you do
a
good.
neophyte at all this stuff, so
Well,
it's good for my Python skills and good for
Yeah.
digital signal processing skills too.
Yeah,
Definitely.
Phil's warning that the transmitters have phase distortion, but if you pick up each of the sidebands individually,
Yeah, I don't
it's
see
not that
I
big
don't
a deal.
understand how the phase distortion is going to cause a problem with,
It shows
just
up as a waveform distortion of the modulation. If you
But-
happen to want to look at the modulation, you'll see distortion.
but if
you look
we're
at the-
But if you just do an RMS,
yeah, if all I
measure
care
of it.
about is the magnitude or the amplitude of those tones, on
That's right.
average for a minute,
That's right.
why do I care?
Yeah, well, just be warned. I mean, it may not be an issue depending on how you process it, but it's just something I've noticed for years.
Yeah.
Yeah.
I guess they
I'd
know
be
it about it,
interested
told
to
them
know
about it.
how an FFT decoding compares, because
Well, I
basically
mean,
that's what we're doing with our AM Doppler. We're doing very
I don't know what you mean by
continual
FFT
FFTs.
decoding. I mean, FFT is a building block. I mean, it can be part of a decoder. Depends on how you use it.
Right. But I'm just saying you kind of have a running FFT going and you pull out the amplitude of the sidebands.
Well, take a look at the waterfall of WWV or
Right.
WVH some night, and you'll see a lot. You'll see a lot of harmonic distortion, which is
Right.
how this phase distortion shows up. And if you look at bring up the IQ mode, you'll see that instead of being a nice horizontal line like it should be for AM, it's going to look like a banana in space.
Right.
Yeah, the phase advances when the carrier amplitude increases, and then the phase retards when the amplitude decreases. It's because they're using plate modulated transmitters on those frequencies that are not well equalized.
Yeah, but again,
Plate modulation's tough to do. I'm amazed that it works as well
again,
as
if
it does.
all we're having Michael do right now is, take a minute by minute averages of the.
That's right.
Yeah, like.
I mean, what I'm saying is that when they're transmitting 500 hertz, they're not going to be transmitting just 500 hertz. It's 500, 1,000, 1,500, so forth. So you build a match filter, you're not going to be exactly matching. That's all.
No, so
those
you're gonna
harmonics
do,
aren't going to carry a lot
like,
of energy.
Right, but Michael,
well, it was pretty bright on the waterfall, but
well, but Michael, you're doing what, 500 plus or minus 20 hertz right now, you said? For your
Yes,
bins?
I think that's the bandpass or the right around 500 or 600. So it should be pretty good isolation.
So
well, it may also enter in if you're going to be looking at the seconds text, which are 1,000 and 1,200. Those are the second harmonics of 500 and 600.
But the tones are blinked during the ticks.
That is correct. Yeah. So if you
there's
time it
25
correctly, that's correct.
10 seconds before and 25
That's on
milliseconds
purpose.
after.
That's correct. Yeah.
So
But they don't
then that's not
interfere.
a problem.
If you are gating your window, that's correct. Yeah. You're gating
Yeah,
the
that's
window.
one thing I have not done. I haven't gated the window to try to really narrow it down on that particular time pulse.
I played with my emulator. I mean, all that stuff is in there, and you could rather than build a filter, you can just use a fast correlator. In other words, you take an FFT of the of the sample signal and an FFT of the receive signal, and you multiply them together in the frequency domain, convert back to time. What you get is you should get nice little correlation peaks at whatever the delay is, the offset.
So you get the time of flight out of this?
Yeah, well, you get relative time of flight. Yeah. I mean, for example, if there is multipath that is long enough, if it's, I don't know what it would be, you would get more than one correlation peak. Although I suspect that the multipath delay spread is not going to be wide enough to be detected in just a few kilohertz of bandwidth. Maybe it is. I don't know.
The side scatter paths are many kilometers longer, you know.
Well,
So,
let's
but
see.
but they're 20
millisecond is 300
right?
kilometers, right? Let's see, is that right?
Yeah, for one sample, if you were to, well, of course, yeah, you're not, these aren't continuous tones, so you can't
Well,
correlate across a 2 minutes, a 2 minute long transmission the
well,
way we could
you
with,
could if things were stable, but of course they're not. So
well,
Yeah.
whenever you do a correlation, you know, you have to decide, okay, how long is my coherent period going to be, and how
yeah,
long is
yeah,
the incoherent period going to be?
yeah.
You
But
have to
with it, yeah, but so if you have a 3 kilohertz bandwidth and 2 minutes, 120 seconds, you can have a long correlation period and narrow the resolution.
non-correlation period,
Right, yeah,
period, right?
yeah.
You probably don't want to correlate coherently. Well, you don't want to correlate coherently any longer than the coherence time, which is pretty short on HF.
Well, that would be. We're talking about WWV.
I mean,
at the moment.
that's
It's
what you're
short.
trying to measure. You're trying to measure Doppler shifts, so that
Yeah.
you know, by definition, it means the coherence bandwidth is not going to be very narrow.
Yeah. Well, we're going to the future. Practically, are we? I think between Franco and Michael and me, I think we have. We'll be creating the data. If we want to add things, that sounds like Michael's work with the tones, that table that you're generating, that you're graphing, but that comes from a table, Michael, of and
Tones
yeah.
schedule.
What's that?
That's correct. It's a tone schedule for every minute of the
Yeah,
hour.
and and well, your intensity values are not in decibels, though, right?
No.
The vertical scale.
It's just amplitude. Yeah.
Yeah.
Yeah,
So
by correlating against my emulator output, I mean, you'd be looking at the composite signal, not just the tone. You'd be looking at the tones and the sound intervals, the blanking and the ticks, all of them. You'd be looking at all those together.
yeah, and how does that help you discriminate Hawaii from Colorado?
Well, but the fact that one is transmitting 1,000 hertz tick, and the other one was transmitting 1,200 hertz, and one's transmitting 500 hertz, while the other is transmitting 600 hertz, and vice versa.
So, I'm sorry, Phil. I don't. I mean, the
You're
technique
looking
that
at
I
a composite signal. I mean, to the extent that the signals transmitted by the two stations are different, you would like to correlate on whatever those are. Now, the 100 hertz subtone will not help you because, as far as I know, they're transmitting exactly the same signal there.
Correct.
But but the tones and the ticks and the blanking intervals are the same. Well, I mean they're different. They're defined by each station, and my emulator will generate one or the other depending on which one you ask for, and it will give you a composite waveform which you can then correlate against whatever it is you're receiving.
Well, that sounds like even much
filter.
more. It's a much more powerful technique than I suggested to Michael, but I wouldn't know how to code that. So you're buying yourself a programming job with us.
You've already done the major part of the work. I mean,
I know. It'd be really easy. You'll probably have it done in half an hour.
Read up on fast correlation. How
I don't have.
Exercise for the
filtering is
student.
a form of correlation, right? Filtering is correlation.
Absolutely. I know the principle, Phil. I just learned that I have to obtain and register and modify my code to communicate things.
You're dragging two waveforms across each other and saying how much these look like each other. That's what you want to. That's what correlation.
Actually, right. I completely understand the concept. It's just learning and implementing is another software, and
that's what fast correlation is for. That's what I've been working on for years.
Well, that's why you could implement it in 1/100th of the time it will take Michael or me to do it. So if you would sign up to help us just do this, it would advance this analysis, I think, immeasurably. Because if you're going to depend upon me, I mean, it's not that I'm unwilling to learn. I'm so honored to be able to, to be tutored by you, but I just don't have enough time to do all of the what is really for me grunt work, software development grunt work of deploying and testing stations and making sure their data is getting up. This is grunt work, but without it, there's nothing to correlate, and that's what I'm still working on that stage of
Well,
it. So
maybe you suggesting Michael do it.
right?
Oh, I'm even worse.
Mhm.
I'm like Icarus flying up way above my
Yeah.
my
Hey,
allotted thing
at
there.
least it's only electrons.
I mean, I think the technique that Michael's doing right now looks like it has some promise, doesn't it?
Yes,
Well,
absolutely.
it's certainly
But yeah,
the first stage of this.
I'm with Phil where it can go, but you
Yeah.
don't have to go there right away.
Yeah, we have something that Michael and I know how to implement and incorporate into a path.
Yeah.
The Phil's correlation approach.
By the way,
is
Phil, I think Dave Costin has been trying some of what you're talking about, but he wasn't having great success.
Okay.
He might be interested in what you're working on there.
Okay.
well, anyway, that's our we've got the IQ wave files. I think we have the raw material. It's now and we have it. I think soon we'll have it going into the Bill's database. So I think that there isn't really the deadline unless there needs to be processing done in real time. The data will be there. Even the 16 kilohertz data will be there for some days past the eclipse. But and in fact, we could just stop and freeze it. I mean, I could have the code save away,
Yeah.
forever, the 16 kilohertz data for the day before and after, 3 days.
That would
And
be perfect.
And then
Yeah.
we kind of then none of us are under any pressure to see how to process this data. We can postpone that activity and concentrate on making sure we get the good raw data and save it away.
I think that's a really good approach. We have this one particular event that we really care about. I fully advocate for saving all the data the day before, the day of, and the day after. And then we can go figure out what the optimal way of doing these estimations are after.
Yeah, what we could learn from the data. I think
Yeah.
that's I think a wonderful result of this conversation. Is
Yeah.
I hadn't really thought about it until just now, but it's easily at all these sites. There's we're talking about well, I have to look at it now. I see what a day's worth of data on 9 bands is, but it's but it's but I'll go look at it. But it's certainly I'm looking at the site here.
And this is the sort of thing like I've had I had an idea for like not this year's Hamsci workshop, but for next year's to have some sort of like a data challenge. And if we could have a nice Eclipse data set that we could post publicly to the community and say, look, here's a specific challenge we want you to kind of figure out, and maybe coming up with the optimal algorithm for separating out WWV from WWVH. Maybe that's a really good kind of grand challenge, and we see who wants to put their hand at it. And
yeah.
Of course we work at it too, but
Yeah. Well, I just went to the KFS site, and the 16 the day's worth of compressed but losslessly compressed data is 26 gigabytes. So that's not so with 100 gigabytes.
if you want to let somebody work on the unprocessed data set, you'll probably have to give them a place to do it rather than transfer that much data to them.
Yeah, yeah. Well, that's a, yeah, they're going to have, well, I have remote access to all these sites, so I can get, you know, we can provide ways, as I have for you, Phil. I've given you remote access to some of the Whisper Demon sites, where you could go right now. You could go to the Ryzen at KFS and do your correlation algorithm on the data there. It's sitting there.
I mean, 26 gigabytes, like, so the Zenodo lets you upload for free in sets of up to 50 gigabytes. And they let you do as many 50 gigabyte data sets as you want. So one way to,
Really?
okay. Yeah.
Ah.
Yeah. So you can have there's a 50 gigabyte per limit per data set limit, but there's no limit on the number of data sets you provide them. So one thing we can do with this is for this particular data, we, you know, for each of the days, if it's 26 gigabytes for that one day for that one station, that's one data set on Zenodo. And, you know, we put that under the Hamside community, and that's an easy way for people to get access to it.
It's fine. It's,
And
well,
and that's permanently there.
well, as Franco says, it's getting late here. But
yeah.
I will mention one thing. I just checked space weather, and there is a G2 class geomagnetic storm possible today.
I've been seeing lots of minor blackout alerts.
Mm-hmm. But there are a couple of CMEs on their way, and there's a fairly large one that may hit us during today. So stay tuned.
Oh, well,
Very
yeah. Well,
73 all.
Okay. Take care.
Thanks.
Thank you.
Okay. Okay. Well, Michael and I guess Franco's gone. I don't see him. And I don't have a problem from the sites I'm at. I can upload kind of unlimited amounts, albeit maybe slowly, but it's.
Phil, thanks to the link to the FT8 repository.
Sure thing. Hope it helps.
Yeah, it's okay. Well, is there action items out of this? I'm going to modify Whisper Daemon and install the version on all the sites that I'm running to cache the raw WAV files and save those 3 days around those dates. And that's and Michael, if you want to make further refinements to what you're doing, we can work together to incorporate it into Whisper Daemon when Whisper Daemon does the processing to create the 24-hour IQ WAV file. It could be also then processing, executing the algorithms that you're, because what I have is, and I can show you where it is. You can actually create those. Is you can take all of the individual minute files and create a single 5.6 gigabyte file that for the 24 hours, and then you could do whatever processing you wanted on that whole 24 hours, and it's all in RAM, so it's relatively fast. So.
Yeah, the machine I have is, as you know, decent enough that I'm not waiting around for hours doing some. And I was working on anywhere between, 2 hours and a whole hour's worth of data.
Yeah.
Just to see what I could get out of it. I do find that it's just, for whatever reason, anytime I try to do processing that involves loading the FLACs, it doesn't turn out right. It really works much better once it's just been obviously converted into a WAV file. But that's just
that's
must
one
be
of
something I'm doing wrong.
Well, you realize that when you're dealing with more than 4 hours of 1 minute files, you're Slack and Socks have to open all those files, or they choose to
Yeah.
open them all simultaneously. So you can bump into the Linux's open file limit, and
Right.
Slack's
No, I haven't been trying to grab that much. I don't have that fast a machine, but
I said, well, that's that you will that I bumped into that and thought it was I was hitting a SOX limit. In fact, I was it's just a configuration limit. You can change the number of open files with a single command. Ulimit allows you to change
right.
all the limits for your user. So anyway, it takes a relatively fast machine a good minute of CPU time to process the 5.6 gigabytes and for SOX to produce the 10 hertz file. So and FLAC decoding seems to be even slower. I think the SOX processing seems to be faster than the FLAC decoding, but I have FLAC decode. You can configure it to create the decoded wave files in a different directory than where the sources are. So I
Right.
leave the FLAC files in the underneath Whistler daemon in the persistent storage space, and I have FLAC output the uncompressed files into a RAM disk. And then I do all the work on the wave files over in the RAM disk.
In the RAM disk. So Nathaniel, the data, the most useful form, well, I suppose in some respects, the most useful form is nice full bandwidth data that you can do post-processing on. But and so if we do what we've been talking about this evening, namely aim to make sure that we turn all these machines on and just gather a wide bandwidth day before, day of, day after, then that is going to solve that need. But it does beg the question of, what kind of monitoring do we do along the way so that when a flare comes or a coronal mass ejection hits today, are we monitoring things and gathering some useful data, and what bandwidth is it worth and how long do we keep it?
Well, I think for now, everything's just trying to get up to the eclipse and trying to.
Yeah.
So I don't think we worry about that too much right now. I think the ultimate, I think the long-term plan is once we do get the eclipse data, one of the things that we need to do, and even along the way, like don't stop doing what you're doing. We want to come up with a good algorithm that does let us in real time be able to say, is this likely WWV or WWVH and how much of each? So I think we do want to have that algorithm, in place and worked out. But I think the problem is it's not a simple answer. There's a lot of different ways to do it. Some ways may work better than others. Some ways may be more efficient computationally than others. Some ways may give a better answer than others. So there's not necessarily one correct way. So I think that's a bit of a research project in itself, just figuring out what the correct way to do that is. And then same thing with like solar flares. We're going to I could imagine having, at some point some sort of a triggering mechanism where, you have the ring buffer going along and then you have some sort of monitoring software looking at it, and all of a sudden it detects a disturbance like a solar flare, or it gets a trigger because it knows that KP went up or something like that. And then we decide based on that, the system will automatically capture full bandwidth data for a certain amount of time and then go back to lower bandwidth data. So it goes into a burst mode for some amount of time.
That's a good idea. Yeah.
But I don't think that's not a problem we're going to solve today. That's not a problem we're going to solve before the eclipse. That's a problem that, the next research grant, or, when we get through with the eclipse or something like that, then we start, looking at those sorts of things. But I don't think that's something we worry about today. And
I got
back
enough worries.
And back to what I said before, I really do believe that, like, people keep saying, well, what bandwidth do you need, or what, you know, we will work with whatever, you know, we can
It's available.
possibly, what's available, because the bottom line is you don't actually necessarily know what you need until you look. So, for instance, super darn radars, they started building them up in the auroral zone at high latitudes because they knew that they were able to see the particular type of ionospheric irregularities when they were located at high latitudes and they were looking at auroral things. And they knew that it would work there because the magnetic fields were pointed down in towards the Earth with a fairly high angle in the high latitude regions. So that's why all the super darn radars were originally built up in Canada. Years later, and when I say years later, I mean like 30 years later, maybe 25, 30 years later, they said, well, you know what? Every time there's a geomagnetic storm, the convection pattern goes equatorward of where the super darn radars can see. So what we really need is another band of radars down at mid latitudes. And originally the scientists said, well, you know what? We're not going to be able to see anything down there. It's just going to be boring data, except for the times when we have these storms. So for most of the time, these radar systems are going to be useless because the magnetic field angle's too shallow in the mid-latitude region. Well, you know what? They built the radar system anyway, and they found out that they had all this great data that they didn't know, and all this great stuff was happening that they didn't predict. And so, but they didn't know it until they looked. And so it's kind of the same thing with the like with the time resolutions, when they say what time cadence we have. If the best we can do, if the best technically we're able to do right now is estimate things on a 1 minute cadence, we'll get some good,
Work with
interesting
that.
science out of it. We'll be able to say something. And then if we come up with a way that lets us, improve it, and we can have better resolution, then we'll be able to say something else. So
Mhm.
so for now, I think just, being able to say, it's WW on a 1 minute cadence, WWV versus WWVH. That is way better than what we have right now, which is essentially nothing. So,
Well, the correlation functions that Phil was talking about reminded me of a conversation a couple of years ago. This guy presented some info on the CODAR radars,
mhm.
and that would seem to me another area
Yeah.
where that correlate. If you could find what the baseline signal is for those CODARs, and then
Yeah.
correlate the similarity between that and what you're hearing
Which I
anywhere.
think Steve Kepler, AD0AE, I think is doing a bunch with that.
Yeah.
So he's a professor down at Clemson, and he's published using CODAR radars.
Okay.
So he just came out with the paper last year about using CODARs to do ionospheric studies.
Yeah, you've been interested in that for a long time.
Yeah, I can find that paper for you if you like.
Yeah, I have some open SDR radios, HPSDR radios that I'd like to put into service. If the RX888's sitting on WWV, I could point those at at some of the CODAR frequencies, and if the math is the same or is similar,
Yeah.
listening to those CODAR chirps, the shape of the signal, of course, is different.
Yeah. Well,
One
there
tone versus.
you can read. I just put in the chat the link to his paper,
Great.
so that'll give you some
Got it.
reading.
Yeah, thank you. Yeah, interesting. Those things are all over the world too, so.
Yeah.
All
Yeah,
right.
and I'm sure if you wanted to get that set up more, like Steve is very friendly, and he shows up on the Hamside telecons every once in a while. He's also incredibly busy, but he'd probably be I would bet he'd be happy to help you get a CODAR receiver up and running for studying ionospheric stuff. And I could
Cool.
certainly put you in touch with him.
Thank you.
Yeah. Well,
All
thank
right,
you
I'm
very.
signing off.
Yeah, me too. Thank you very much, everybody.
Good night.
73.
night, everyone.
night.
Okay,
Have
take
a
care.
good afternoon.
73. Thanks.
7-3.